Hello fellow learners, welcome to Maths Bridge. I hope you are all doing good. Thanks for joining with us. We shall continue our learning journey in C programming. Guys, keep up your motivation energy levels to learn new things every day. Without further delay, let's get into today's topic. Shall we? Folks, please do visit us at our YouTube channel Maths Bridge. I'm sure I think you are already subscribed to the channel. If you have not, please do subscribe the channel and then support us. Thank you and then happy learning. Here is our today's agenda. Today we're gonna look at each data type versus how memory is getting mapped to it. Okay, this basically give you like a kind of a illustration of how memory is being utilized for each data type. The other way around, memory is being allocated for the variable of specified data type. Okay, if you can see a first case as a character as a data type, look at this sample program where I have three variables declared as data type char and assigned value to it. Right, char is holding 1 byte information. Right, 1 byte means 8 bits. What we were trying to do here, I try to print both address and value which is stored in that variable. Right, so we are doing for three variables, and then the last statement is line number 17 is size of char means like out. So this is what we're gonna see. If you can compile and print the values, then this is what the output that we got it. Addresses and then the value which stored in that address is what we could see as an output. And then this, you look at size of char is nothing but 1. So 1 byte is what the char means, right? So when you declare a char variable, that means like 1 byte of memory getting allocated for this particular variable. Right, so let's look at like a kind of a memory mapping. So to illustrate this example in pictorial representation, let's say we have a memory of 1 byte with memory locations. Right, all is like a 1 byte 1 byte 1 byte. That is how your memory, imagine. Right, so if you can see something like this, so each location is like can store only 1 byte information. This is how that you have a memory. Okay, so what we were doing now, try to put some kind of an address. So because that is how I'm getting, right, 81 82 83 and all. So I'm just mapping three values. So I have 81 82 and 83. U means unsigned value when you say here. So addresses, right, address is always like a kind of an integer value. So that's why unsigned integer is what I am displaying as an address here. So what's the value that I am storing in, you look at this one, right? The address end with 83 is where I'm storing A, address end with the 82 I'm storing B, address end with 81 I'm storing C. Right, so variable 3 is actually you see as a 81 this place. Correct. Right, so 80 83 is a place where I'm getting A. So A filled in this address location, and then the symbolic name for this address location is what? C var 1. That's a variable. And then address end with 82 where we are storing B value. This is correct. So symbolic representation for this memory location name given as a C var 2, char var 2, variable 2, isn't it? and then see where 3 is at 81, the value stored in it is like C. Do you see this one? So memory is organized in 8-bit, 8-bit or 1 byte locations. So char requires 1 byte for each variable, and hence first 3 bytes, if you can see, those are getting allocated for these 3 variables. This is how memory is getting allocated for variable of specified data type. Now next case is like an integer. Let's look at the same kind of a program, but instead of character, now we are actually working for integers, ints. I have a 3 integer variables, and getting assigned with the values 100, 200, 300. Now I am printing both address and value of each variable, right? This is a kind of a syntax that I'm using. This means like an address ampersand as a prefix, you see. This means like address of operator as a prefix to the variable means you are referring a memory location. When it is an address is always like an unsigned integer, right? So that's why ampersand use what I am using as a format specifier which prints the address. This one is like an integer value, the value of this variable, the variable which holds certain value, right? The integer value, the value is what you are displaying using percentage of d. So this is similarly I do for the variable 1, 2 and 3. So if I could see, like wanted to see the size of the integer, how much, that also I was printing here. So if I can compile and run it, this is what my output is, right? Size of integer is like 4. What this means is, like, if I would think of my memory snapshot, this is what I think I could see, right? What we discussed is like 1 byte with memory locations, what I am having, but each variable requires a 4 bytes is what integer meaning, right? Irrespective of what are the value that you are going to store in that variable, but still the memory is getting allocated for each variable is 4 bytes, right? If you could really see the mapping, then you could correlate what I am trying to say. Okay, so let's say 72 is the memory location, address of the memory location for I num3, because that is what the value. So 72, 73, 74, 75, is it? So these 4 bytes are allocated for this one, this variable inum3. If I go back to see the next address 76, that's where the second variable, so inum2 is getting allocated. So from here again 4 bytes, because each variable requires 4 bytes, that's the size of integer is 4 bytes. So 76, 77, 78, 79, right? So the third variable so will be allocated from address and with 80, right? From there to 4. Do you see this one? Irrespective of the value that you are storing, but still you could imagine that how many bytes of memory is getting allocated for each variable. So it is very essential for us to understand whether we require a integer variable or char variable or unsigned variable or the double variable. If you don't specify them properly, then you are indirectly losing the memory, meaning you are underutilizing the memory. So but wise thinking for the a good programmer is always think wisely how much memory is really required for your data type, and then declare that specific data type for that variable. Okay, that's the illustration. So what is the value that I'm storing at 80? 80 I am storing 100, because this is a logically symbolic representation for your I num1, and at middle I am actually storing 200, which is I num2, and then the top and 3. So I am just trying to cover this as like, these 4 bytes of information. I mean, these 4 bytes basically look allocated for this particular variable which is holding 200. How it is actually getting mapped into it, and that is not I'm talking, but logically you can think through. Even though your number is small, but still you require 4 bytes. That means like 4 byte of memory is already getting allocated for that variable, integer variable. So next case would be float. So I have the same the sample program, but data type declared as a float. Okay, the size is again the 4 bytes. If I can compile, and this is what my output would be. So you could guess, right? So the value that I'm storing is, even though I'm assigning like the whole number, but the float is always converting into the decimal format. So after decimal there would be 6 digits. After decimal is what it is getting loaded, right? So I could see from my output. Now let's see like how you are going to map these to memory locations. So since I am saying like my size of float is also 4 like an integer, now I would see like this is a 4 byte segment is what I'm using for each segment is allocated for each float variable. So if I can map it, so this my 72, the address where I am storing 376, address end with 76 is where I'm storing 200, and then 80 at which I'm storing 100. So the values are like 100 and dot 0000, 200 dot 00000, and then 300 000. This is how you see. So the way that value is getting loaded into it is I'm not actually describing in the detail, but logically you can imagine like how these values are getting loaded into specified length of memory location getting allocated for that variable type. Are you clear? See, if at all I would want it to actually see the size of each data type, like a char, int, float, double, short, long. This is a sample program which basically gives me size of each data type. Okay, in this context I could see char is 1 byte, integer 4 bytes, float 4 bytes, double 8, short 2 bytes, long 4 bytes. This is how I can see, right? The size of is always returns an integer value, and hence my format specifier is percentage of d. While writing a program, one way or other you might need to understand one topic is like a data type conversion. So sometimes there is a need of actually copying value from char data type to integer data type, right? Or integer data type to char data type. So the part is like when you have a different data type sizes, the sizes are different for each data type, then copying from lower size to uh, larger size, and or the larger size to lower size of data type, what you might end up seeing it out, there could be a data loss, isn't it? To illustrate that example, let's say like I have the big jar and then small jar. If I'm trying to pour all the liquid from the big jar to a small jar, what would happen? There may be overflow. There must be a overflow, right? So that means like you are dropping some of the liquid out of the small jar, because you can't fit the amount of liquid that the this bigger one is holding might not be the same in the smaller one, right? So I'm illustrating this as a, like a data loss. Okay, the other way around, if you are actually trying to copy, means like pouring all the liquid from the smaller jar to the larger one, bigger jar, then complete liquid of my small will get into larger, where I don't require to really lose any data. However, yeah, there is a conversion concept where you might end up losing data. For instance, integer and float both actually requires 4 bytes of information. I mean 4 bytes of memory location. However, integer is not going to hold the fractional part like a float. So when you are copying value from the float to integer, the fractional part is what you are going to lose it. So likewise, you just see the sense of like a data type at what value it is holding. When we do convert, like what you might lose. Okay, this is one essential topic that one should have to understand while writing a program or converting the data types. Here is all C supported data types and their sizes. Okay, char 1, short 2, int 4 bytes, unsigned int 4 bytes, long int 4 bytes, unsigned long int 4 bytes, float 4 bytes, double 8, long double 16. All right, this is very good concept. Here is the conversion hierarchy. Okay, short, char, int, unsigned long int, float, double, long double. Okay, this is an order, lower to higher. The float to int causes truncation of fractional part. I think that we discussed. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.